Word problem involving an ellipse. The arc of the bridge below is half an ellipse, a semi-ellipse. As shown in the figure below, the arc is 160 meters long and has a height of 52 meters at the center. The height of the arc is 18 meters at point P. Find the distance from P to the center. Round your answer to the nearest hundred. Do not round any intermediate computations. First thing we're going to do is actually imagine the entire ellipse. So imagine this lower half right here. That way we're envisioning the equation of an ellipse in its standard form. Let's conveniently label our center to be the origin, 0, 0. And if you notice that is the origin, then we know that the major axis is actually along the x-axis. Okay, so the major axis is along the x-axis. That means our standard form of our ellipse is x squared over a squared plus y squared over b squared is equal to 1. You know, where h comma k is what? H comma k is 0, 0, right? That is actually our center. Now we also know what a is. A, of course, is greater than 0, and b is greater than 0. A is representing half the distance of the major axis. So a is actually 80. So a is 80. B is half the distance of the minor axis. So b is 52. Now our goal is to solve for p. Now if you look up carefully up here, there is a dot on the ellipse, and the label for that dot is going to be a p, comma 18. And our goal, of course, is to solve for p. Notice p, comma 18 is on the equation of the ellipse. Now before I plug in the 18, let's just focus on p. Why don't we just solve for p? So p squared, and we'll let y be y. But we're going to focus on solving for p. And that way we get a formula to get p. What do we have here? Add y squared over b squared is equal to 1. So our goal right now is to solve for p. Let's clear the fraction. Let's multiply the entire sides by a squared times b squared. Let's see what we get. We get p squared here times b squared, right? And then plus an a squared times y squared is equal to a squared times b squared. P squared is equal to a squared times b squared minus a squared times y squared. And we know that b is not 0. That's really important. From the previous line, we know that b is not 0. So we're going to divide the entire sides by b squared. What do we got here? We got p squared is equal to a squared over b squared times what? Times b squared minus y squared. All right. Now we could take the square root of the entire sides. So we get p, or the absolute value of p, how about that, is equal to the square root of a squared over b squared times the quantity b squared minus y squared. So what does that mean? Absolute value. So p has to equal plus or minus a over b square root of b squared minus y squared. Now we also know that P is what? Well, P is representing a positive distance along the positive x-axis. So P is greater than 0, so that means we really have a formula that says P is equal to A over B times the square root of B squared minus Y squared. Now we're ready to substitute everything. P is equal to A. A is what? 80 over B, which is 52. Square root 52 quantity squared minus Y. Y was what? Y was quantity 18 squared. And then plugging this into your calculator, let's see what you get. We have 52 times 52 minus 18 times 18. Now I'm going to take the square root of that. We get a number. I'm going to multiply that by 80. I'm going to divide by 52. And we get this number. 75.0542, and of course it goes on forever. We're going to round to the nearest hundred, so we're going to look at the thousands place. 4 is less than 5, so we're going to round down to 75 and 500ths. And let's figure that out. Let's write that in a complete sentence. The distance is 75 and 500 meters from the center. Certainly you can circle the final answer, but as usual, it's very important to show all your work. And so the recap here is make sure you label your origin. Label your origin, and then solve for the missing value. In this case, our missing value is P.